Ever wondered how protons and neutrons, the building blocks of atoms, came into being? To understand the origin of these subatomic particles, we have to embark on a cosmic journey, back to the very birth of the universe itself. The Big Bang Theory, the prevailing cosmological model, tells us that the universe began as a singularity, a point of infinite density and temperature around 13.8 billion years ago. In this incredibly hot and dense state, the universe began rapidly expanding, cooling down as it did so. In the early stages of this expansion, a fascinating process took place. Particles and their counterparts, antiparticles, were created and annihilated in specific ratios. These particle-antiparticle pairs would collide, annihilating each other and releasing energy in the form of photons. As the universe continued to cool and expand, the energy levels dropped. This led to some intriguing changes. Certain particles, such as quarks and gluons, began to combine, forming protons and neutrons. This process, known as hadronization, was a critical step in the formation of matter as we know it. Particles continued to decay and annihilate each other, but not all were destroyed. Due to a phenomenon known as baryogenesis, there was a tiny excess of particles over antiparticles. This minuscule imbalance meant that when particle and antiparticle met and annihilated each other, there were a few particles left over. These survivors are the protons and neutrons that make up the atoms in the universe today. So the origin of protons and neutrons is deeply intertwined with the birth of the universe itself. Ever thought a proton could be complex? Think again. With their intricate structure, protons are far from being the simple particles we once thought they were. Peering into the world of the incredibly small, we find that a proton is a bustling city of particles, each playing its unique role. At the heart of this microcosm are three valence quarks. These are the proton's primary building blocks, the fundamental entities that give it its identity. But the quarks are not alone. They are held together by particles known as gluon. These aptly named particles glue the quarks together, all while zipping back and forth at blistering speeds. Yet the proton story doesn't end here. Delve deeper, and you'll encounter a sea of quarks and antiquarks. These particles are continuously created and annihilated in pairs, creating a frenetic dance of matter and antimatter within the proton itself. This is not a calm sea, but a stormy one, teeming with activity. So, how does all this chaos fit into a tiny proton? The answer lies in the delicate balance of forces at play. On one hand, there's the electrostatic repulsion between the positively charged quarks. On the other, there's the attractive, strong nuclear force. This is the strongest force in nature, and it's what keeps the quarks huddled together, preventing the proton from blowing itself apart. In essence, a proton is a microcosm, a miniature universe of particles and forces continuously interacting in a delicate dance. It's a testament to the incredible complexity that lies at the heart of our universe, hidden within the smallest of particles. So a proton isn't just a simple particle, but a miniature universe in itself. Ever wondered why neutrons without any charge play a crucial role in the atomic world? Well, let's dive into the nucleus of an atom and see what's happening there. Picture the atomic nucleus as a bustling city where protons and neutrons live side by side. Now, protons, they're the charged citizens of this city, always carrying a positive attitude, if you will. But this positive charge can cause some trouble. You know what they say, like charges repel, and that's exactly what happens. Protons tend to push each other away, threatening to tear our atomic city apart. But wait, here come the neutrons to the rescue. Neutrons, the uncharged peacekeepers of the atomic city, step in to keep everything together. They mix with the protons, reducing the overall repulsion between these positively charged particles. By doing so, they help to stabilize the nucleus, maintaining the structural integrity of the atom. Besides being the glue that holds the atomic city together, neutrons also contribute to the mass of an atom. Despite having no charge, neutrons are nearly as massive as protons. Therefore, they account for a significant portion of the atomic mass. In other words, they give substance to the atomic world. Their role doesn't stop there, though. Neutrons also play a key role in nuclear reactions, such as those occurring in the Sun and other stars. These nuclear reactions involve the transformation of neutrons into protons. with the release of a vast amount of energy. This energy is what powers the sun and, by extension, all life on Earth. So, neutrons play a vital role in keeping the atomic world stable and balanced. Without them, atoms would disintegrate, stars would cease to shine, and the universe as we know it wouldn't exist. So, let's hear it for the neutrons, the unsung heroes of the atomic world. Ever wondered how protons and neutrons interact within the nucleus of an atom? Well, they don't just hang around there randomly. There's a whole lot of intricate dance going on. Let's dive into this microscopic world. Imagine a bustling city where instead of people, we have protons and neutrons. They're constantly interacting, held together by a force more potent than any on Earth, the strong nuclear force. This force is so powerful that it overcomes the natural tendency of protons to repel each other due to their similar positive charges. Now, the strong nuclear force is like the gravity of our atomic city. It pulls protons and neutrons together, creating a balance against the electrostatic force trying to push the protons apart. This equilibrium is what keeps the nucleus stable and the atom intact. But there's more to this dance. Protons and neutrons don't just stick together, they exchange particles called pions. Picture these pions as messages passed between protons and neutrons, a constant conversation that keeps the strong nuclear force in check. And here's the fascinating part. This whole interaction happens in a space smaller than a trillionth of a meter. It's a microscopic ballet of forces and particles, choreographed to the laws of quantum mechanics. So the interactions between protons and neutrons are what essentially hold an atom together. It's a complex dance of forces, a testament to the intricate beauty of our universe, even at its smallest scale. Our understanding of protons and neutrons is ever evolving, thanks to the relentless work of scientists worldwide. Every day, in labs and research facilities scattered across the globe, they delve deeper into the mysteries of these fundamental particles. Take, for instance, the Large Hadron Collider, the world's most powerful particle accelerator. Here, protons are propelled close to the speed of light, colliding with such force that they shatter and reveal even smaller constituents. It's like smashing a watch to see its inner gears. These high-energy experiments have brought us closer to understanding the structure and behavior of protons and neutrons. But it doesn't end there. The quest is ongoing, a pursuit of knowledge that's as infinite as the universe itself. Even as we speak, scientists are devising new experiments, formulating new theories, and creating more advanced tools to probe the heart of matter. It's important to remember that these particles are not just abstract concepts. They're the building blocks of everything around us, from the screen you're looking at to the stars in the night sky. The better we understand them, the more we comprehend the universe and our place within it. So the journey to fully understand protons and neutrons is a never-ending one, filled with exciting discoveries and revelations. We hope you enjoyed this cosmic journey into the world of protons and neutrons. We've explored the intricate structure of these fundamental particles, their vital role in the universe, and how they interact. The exploration is far from over, though, as the mysteries of the universe continue to unfold, challenging our understanding of the cosmos. If you found this video enlightening, do give it a thumbs up, drop a comment with your thoughts, and share it with fellow science enthusiasts. Remember, the universe is full of wonders waiting to be discovered. Stay curious,